Oh, I'm at the ACX Meetup London, and today I'm collecting entrainment data from a couple of participants in the headset to do a demo of my application.
The study found that entrainment, flash and white bright light at the frequency of a person's alpha rhythm, helps them learn to perform a certain perceptual task faster. Here you see someone's brain getting entrained, them doing the task and getting feedback on the screen, a small green check mark or a red cross. The task is distinguishing between two types of patterns, radial and concentric ones. The top patterns are prototypes, very easy to tell apart. The bottom ones are noisier, they are the actual task. Participants get shown the kinds of patterns you see on the bottom, and only for 200 milliseconds. And they also get only 1.5 seconds to indicate which pattern type they just saw by pressing the left or right key on the keyboard. And here is the second participant doing the same task. You might notice that the flicker is higher frequency this time. Now, how do we find out this frequency? To do this, we record the participant's brain activity for a few minutes while they stare at an empty screen with a fixation point. This is to make sure the conditions are similar to the task conditions. Then, we look at the power spectrum and find the peak frequency in the alpha range, which is typically between 8 and 12 Hz. The power spectrum summarizes brain activity over a given period. It looks a bit similar to a music equalizer, although a music equalizer allows you to adjust frequencies. And here, we are only measuring them. One of the core claims of the original study is that not just entrainment matters, but also how you time the patterns. You can time the patterns with a peak or a trough of a person's alpha rhythm. And people learn faster when you time stimuli with the trough, even if the entrainment is the same. The application aims to validate this key claim of the study. So, what does it mean to learn faster? In the original study, the authors had the participants solve 8 blocks of about 100 patterns each, and on average, people's accuracy increased faster when you timed patterns with troughs compared to when you timed them with peaks. You can see this on the chart in the top left. T-match means timing with troughs and then training at a person's alpha rhythm frequency. P-match means timing with peaks and the same kind entrainment. Like I mentioned, it's not just about entrainment, it's also about the timing. At the ACX meetup for the demo, I had 2 meetup attendees solve 40 or 50 patterns in both of the 2 conditions, T-match and P-match, in a double-blind fashion. This is more than an order of magnitude less patterns each participant solved in the original study. I was only doing a demo of the common application. I have yet to start collecting data for the full thing. But what can we see from this little demo? This is the second participant's results, the one you saw last. They solved 50 patterns in the T-match condition, split into 5 blocks of 10 patterns each. Then they did the same for the P-match condition. This number of patterns is not enough to estimate the learning rate, although you can see the dashed linear fit just in case. The interesting point is that the accuracy was 8 percentage points higher in the T-match condition than in the P-match, despite the disadvantage of the T-match being the first one. The other participant had the P-match condition first and the faster learning T-match condition second. And the accuracy difference was even bigger in this case, 17 percentage points. There is clearly something interesting going on with the T-match condition. Of course, there is no guarantee that higher accuracy translates into faster learning, and we are after faster learning and not just higher accuracy. But we can also speculate that if the brain processes data more efficiently with higher accuracy, maybe it's also learning faster. So I'm personally very optimistic about the study actually replicating. And another reason I'm optimistic is because I myself solved a few hundreds of those patterns in each of the 2 conditions. And I felt like I was learning more in the T-match one. I had like more information available for perceptual processing. This might sound like bullshit, but that's how I would explain it. And also I could backtrack my reasoning more in the T-match one. Like I would guess the pattern wrong and I'm like, yeah, I can see why that pattern was the radial one and not concentric one, or the concentric one or not the radial one. Finally, you can help the project by signing up as a participant in London, or if you've got your own EEG hardware as a remote participant. The links are in the description. Thank you for watching.